Hi, my name is Arama Karikari. I'm a solar manufacturing engineer for Project Kuiper, which is under Amazon. And what keeps me excited about engineering is being able to see the products come to life. And recently we just had a launch for our proto satellites, so it was really cool to see it up in space.
Hi, my name is Victoria Pafnuk, and what excites me most about engineering is being able to see your product in the real world and knowing that you contributed to making it happen.
I'm Rachel Harris. I work at Starfish Space, and one thing I really enjoy about engineering is being able to think of a product and then make it a reality through design, build, test, and iterations. It's really neat to create something that you had considered.
I'm Erin Reynolds. I'm a mechanical engineer at Korry Electronics located in Everett, Washington. What makes me passionate about engineering is having an understanding or a curiosity for things below the surface. Understanding all the building and technology that goes into and the effort that goes into everyday objects, and being able to understand that it's more than just a simple car or a phone or even a chair, and having a level of appreciation for that.
All right, let's get started. I'm your moderator, Stephanie Maxwell. I work at Orion Industries, an aerospace manufacturer, and I've been on the board of WIM, the Washington chapter, since 2020. And we're here to discuss our engineering and design fundamental part of our series, as Heather mentioned. And with that, I'll just get started. I'm going to let the panel go ahead and introduce yourselves and tell us about your journey to becoming an engineer and how you got started in manufacturing. I'll start with Arama.
So my name's Arama Karikari. I'm a solar manufacturing engineer at Project Kuiper. And prior to that, I was actually getting my master's in mechanical engineering focused in robotics and mechatronics. So why robotics and mechatronics? I've actually always been interested in that aspect. I was part of the high school first robotics club, and I became the president in the last year. So through that club, I experienced what it was like to apply sort of math science in the real world. And it was fun because we were playing games that you would think would be like a sport event. And so from that, I was like, oh, I want to focus in engineering. And I am actually from this area, Washington. I wasn't born here. I was born in Ghana, but I grew up in Washington. And one of the reasons why I stayed in Washington was the program called STARS. Basically was like, hey, do you want to come to the University of Washington and be part of a program, which is a program to support people who are excelling in high school but don't have as many resources. For example, I'm first generation, so it would be very difficult for me transitioning throughout college. And they support us through workshops, through career development, and then interacting with faculty. And then at the end of the program, you're able to apply to your top three, and you're guaranteed your top three. And I got my first choice, which was mechanical engineering. So throughout the years at UW, I gained lots of mentorship. And one of the people in the program encouraged me to participate in the Ronald E. McNair Scholars Program, which tries to get people to pursue a graduate degree. Most of them pursue PhDs. I happened to go the route of a master's just because I wasn't sure if I wanted to continue with research. And I think for me, that was a good decision because through that program, I was able to get a fellowship. That's the GEM fellowship. And one of the aspects of the fellowship is you're sponsored by an industry partner. And my industry partner was actually Amazon. So I was able to intern with them for 2 summers. And the program was called Amazon Glow. Is no longer in existence, but it was a really good idea of interacting distant family members through a device and a playmat. So basically you could read with your grandparent who's abroad. Unfortunately, they didn't have a head count. So I got put into a pool of other interns who excelled at their internship, but were looking for opportunities. And the recruiters from Kuiper reached out to me, and I talked to the director of engineering. He's like, you are a good fit. Come join Kuiper. So that's how I ended up at Kuiper, knowing nothing about solar panels and satellites. And in the last 2 years and 4 months, I've grown as an individual and as an engineer. So, yep, that's me.
Awesome. Erin?
Yeah, I'm Erin Reynolds. I'm a mechanical engineer at Korry Electronics. I had no idea what I wanted to do, especially in high school. I had no idea what engineering was. I wasn't super crazy technically involved, and I just knew that I slightly liked science and math. I actually had an older brother who pursued engineering right before he left. He was like, okay, I got to figure something out. I was like, okay, yeah, that sounds like a good idea. I'll kind of go that way. I went to community college for 3 years, and then I transferred into a university. During that time is probably where I actually figured out that, okay, I got really lucky. I decided to pick engineering. Because again, I didn't know what it was until I actually got into it. As soon as I started figuring out, okay, like, what is engineering? Oh, you can look at anything and start to understand and understand the background and start to question and want to actually see something more than what it is at a surface level. You start looking at your phone, you start looking at your car, you start wondering, oh my gosh, how does this all actually work and come together? And that felt like in some way a superpower to me. And I felt like that really reinsured my interest in pursuing engineering. In my junior year is when COVID hit. And at that time is when I was applying for internships. I applied at internship at Korry Electronics. And I got rejected because, everybody was laying off their own employees and everything was going crazy. I tried again my senior year. I got an internship. And then during my internship at that time, I communicated with the right managers and all the people around me. And they decided to hire me on as a full-time mechanical design engineer. So that's where I'm at right now.
Awesome. Vicky?
Hi, my name is Vicky. I have to start with a confession. I'm not an engineer, but I did choose the science route, so I'm still from the world of STEM. Currently, I work at a company called Kwik. If you're part of our Yakima series, that was one of our stops. So if you've ever bought a loaf of bread for your sandwiches and then you open and it's got the little plastic piece to keep it closed, that's what Kwik makes. So I'm in charge of our sustainability efforts and looking at new materials so that we can be more sustainable through our packaging. I'm not that far along in my career. It's my almost 3 years at Kwik. And before that, I guess I'll start back a little earlier from when I was a student. I just knew I wanted to do something technical. I really liked math. And then I took chemistry and thought it was really cool. It made a lot of sense. And deciding between engineering or science, I decided to go the science route. And being a student who just loves learning, I decided I want to be a student as long as possible and ended up with a PhD in chemistry. So during that time as a graduate student, I was pretty intentional about making sure that the knowledge I learn is, if you've ever heard, more of a T shape. So you have vertical where you have something that's narrow but very deep. So my thesis, but also broad, the horizontal part, but not deep, shallower. So being able to take advantage of opportunities like, for example, at the University of Washington, they have a Office of Commercialization. So any ideas that come through that could potentially be patented or turned into startup, they get screened through that office. So that was where I got to think more about how can you make technology work for people and exist as a product. There was also another program that had PhD students take part in an angel investment firm and be able to see how do these investors evaluate all these different ideas to come through. So it was great to take advantage of the flexibility you have as a student and be able to explore and kind of figure out what I wanted to do. The further I went along with my research, the more I realized that I actually didn't want to continue doing it. And it was just really through my network that I ended up at Kwik with somebody who was at the time at Boeing, and I had really no intention. I just wanted to practice networking, but yet that led to a job. So even though I'm not the one who really likes networking events, I have to say it does work. And so it's been very exciting to be able to go from a lab where you're asking lots of questions and digging into all the details to moving into something that you know is everywhere. And, people don't know the Kwik company, but they definitely know our product, and be able to say that, any launch, this is something I've worked on, is very rewarding.
Awesome. And Rachel works here at Starfish. So tell us about your journey to getting here.
Yeah, I'm Rachel, and I work at Starfish, and yes, I did write notes down for my introduction. I tend to ramble, and we can't have that on camera, so. So I got this job with zero networking at all, actually. Found an application, applied, was like, oh my goodness, space robots. I'm a mechanical engineer here at Starfish, so I do the hardware development for basically our grabber mechanism that grabs onto other satellites. I was not planning to become an engineer at all when I was little, because I didn't know that was a real thing that you could actually do. I actually went into undergrad as a kinesiology major, and then I discovered that even though I think the way joints work is really, really cool, that translates much closer to, mechanical engineering than it does to physical therapy, actually. Majored in engineering. I worked with the Oak Ridge National Lab large-scale additive manufacturing for a while, where I was working on giant welding robots, which was so much fun. Just take a robot, make it 3D print things, and then you end up with a car or a house or some incredible random blob of metal that takes a ton of post-processing. But that was a good time. But I don't know, I had loved the concept of space from a very long time. I remember seeing Curiosity launch and being like, oh my goodness, there are robots on Mars. They're the cutest thing ever. Oh my god. Curiosity still has a special place in my heart. But also, Perseverance is great too. But then when I saw an application to build space robots, I assumed I couldn't get it. But I knew I had to try anyway, because none of the other jobs I was looking at the time were anywhere close to as exciting. And then I moved out to Seattle, started working at Starfish, and have been here ever since.
Awesome. Thank you all. Listening and getting to know you all, I've learned your day-to-day life is pretty erratic and kind of spontaneous. So what does a typical day look like for you in your professional career? I'll start with Vicki.
Sure. So, again, I'm not an engineer. So my current title is Sustainable Product Development Manager. So really what this means is that I have to see a product from its conception as an idea all the way through a product launch. So really it means being involved in every department and making sure it's going through all the steps. We have the right people involved in conversations and divisions. So we'll go from understanding our market to working on R&D. There's a lot of collaboration that happens there. So since we are a manufacturing company rather than an R&D company, we work a lot with other folks who know different materials very well and have the resources that we don't. And then from there, once we're able to look at new promising materials for different products, we can move into our own production and involve testing, being able to make sure that it's able to go through all our processes and behave as we expect. And then moving back into then engineering and sales and being able to think about what kind of claims can we make about our products? Do we need certifications? How do we really present it? So it's really on any given day, I'll have to talk to anybody from any part of the company and lots of meetings and coordinating. I do still do a bit of lab work too, but it's quite collaborative for sure.
When I was in Yakima, I saw your lab. I got to tour Kwik, and it was pretty impressive. And it seems like you really own that lab, so that was pretty cool. Rama, what does a day look like for you at Amazon Kuiper?
So, like Vicki, it also varies from day to day. Usually I try to be as organized as possible. So I have an hour in the morning for planning for the day. That does not work out because I'll get brought into the floor because of an issue because of the day before, or I have a meeting with one of my coworkers about some issue. But Usually we start off the day with a stand-up with the production team to learn about what happened and what we want to do for the day. And throughout the day, I have boring meetings, which definitely require my input a majority of the time, but other times they're just more to get information about what's going on in the organization. I also work on sort of routings that help the operators perform their jobs. I work on improvements to the process and then also analyze what's happening and the data that we got from the process. And I also work on future buildings, which we're trying to get into our production phase. So basically developing our new solar line and working with vendors and communicating different needs.
Awesome. And I'm sure as an engineer, there's a lot of ups and downs with design and getting that design into production. So talk to me about some pivotal moments in your career or achievements that you want to talk about. Start with Erin.
I was just rethinking from last time I spoke about this, realizing what was actually more pivotal in my career rather than making my first product. In a weird way, the most pivotal point so far into my really early on career was one time we were in Material Review Board, or MRB, and there was some situation that was going on. Oh my gosh, we're losing money. Oh, this problem, that problem, blah, blah, blah. I'm sitting there and they all look at me and they go, Erin, what do you think? And I'm like, wait a minute. wait a minute. People care. People care about what I think. All right, cool. That's awesome. It reminded me back to when I was working part-time at Panera. If you like Panera, well, good for you. I don't. Just kidding. I do. It's a great food place. I remember sitting on the bed one time at 4 a.m. in the morning, getting ready to go in at work. And I was like, oh my God, I don't want to do this for the rest of my life. That very moment at that MRB table, Material Review Board table, when everybody was actually coming to me and Erin, so what do you think? You're the responsible engineer. I was like, wow, this is what I did this for. I get to have that opinion. I get to have that input. I get to think about everything I'm doing as I come in. It wasn't necessarily like this crazy achievement, but for me, it was like, oh my gosh, wow. I guess I am an engineer, and I guess I can think about it. And every day I'm going to come into work, something's going to be different, and I'm going to have an impact. So.
Awesome. Rachel, what about some of your pivotal moments in your career?
Well, the first one that comes immediately to mind was probably launching a satellite to orbit. I did not launch the satellite to orbit. I simply watched from directly above us while the satellite went up on Falcon 9 and separated. But it was just so cool to have things that I physically, designed and assembled in space. I don't know. Pretty exciting. Definitely here for that. And it's the sort of thing that I had haphazardly fantasized about doing for so long, but never actually intended to do because, some dreams are just dreams. And then it casually happens. And I'm like, oh, good to know. I'm here for this. And then another much earlier on that comes to mind is I, like Irama, was on a robotics team in high school, and this one time there was a robot that was supposed to grab and move large trash cans, and I suggested a very simple change for it in between quarterfinals and semifinals. And we made the change and won the match and made it to finals. And afterward, my robotics mentor came over and just casually put his hand on my shoulder and was like, I knew we kept you around for something. And he meant it entirely as a lighthearted joke. But to me, I was like, hold up. I just did a thing. I should go do more things. So then I became an engineering major and I did more things.
And still are. So building off those pivotal moments, have you ever had struggles prioritizing your personal life from your work life? And what does that kind of look like? What are those difficult choices you've had to make? Start with Vicky.
Sure. So to give a little bit of background, my family is an immigrant family, so I'm actually the only one in my family born in the U.S. And that, of course, comes with its own struggles, trying to transition culturally. Because we came from the former Soviet Union, we were very poor and, had a lot to work for to make something of ourselves. Our parents definitely sacrificed a lot to get here. So, I mean, part of growing up with a community of people from the former Soviet states, one of the expectations for women is that you get married early and you have children as soon as possible. And I definitely am not one of those people. So that was, as much as it might be a little more joking, was difficult to kind of change your identity in a sense. And so when you've identified with a group of people and really been involved for a long time, and you begin differentiating yourself and making decisions that really make sense for you, you kind of have this world where you're kind of neither here nor there generationally as well. And so that was difficult to accept, but I was able to do it because I believed enough in my own decisions and be able to say that I want to be able to continue going through school. I see value in it. I want to be able to have choices in my career that I find meaningful and be able to also have financial stability with that so that later I am more prepared for the choice of a family and children. And so even though it's maybe something that was different, it was worthwhile, and I don't have any regrets. I will say also that having a healthy dose of I don't really care what people think can really take you a long way, because you really can't please everyone. That's impossible. Thankfully, the people closest to me didn't give me a hard time about it, and so I was able to continue that route. And so I'm thankful with how far I've made it.
Awesome. Hey, Rama, what do you have to say about that?
So I would say my first year at Project Kuiper was pretty hectic. Like I was saying, I knew nothing about solar panels. And so like for me, my mentality was work as hard as possible, get to know as much as possible, excel in literally everything. And how that turned out was starting at 6 a.m., ending my day at 7 p.m. We were sort of in a phase where we had vendors on site and we were trying to commission and bring on our pre-production line. And like, that was horrible. And that, like, I could feel myself burning out from that, just recollection of that moment. And so I don't know when that happened, but I think it was like between like, after that instant, I decided to start setting alarms for myself, to leave at like, so if I start my day at, let's say, 7 a.m., because I'm no longer doing the 6 a.m. thing, I would set an alarm for 4 p.m. to be like, you need to get out and then you need to stop talking to people. Just so I have that like recollection that I need to go out and do more with my life, because the job will still be there the next day and I'm still doing a good job. My manager is not like upset that I'm working less hours. So just having that mentality switch and having that cue like, hey, you need to leave because sometimes you just get distracted was how I distinguish sort of like a break between work and personal life.
Good takeaway. Only work 40 to 50 hours a week. Do not work more than that. Erin, tell me about a time that you had to balance your personal and professional priorities.
To some extent, when I was choosing to try to get a job for the first time after graduating, I did a balance of trying to figure out, okay, well, where are my options? Where can I go? At the time, I technically still am. I had a boyfriend who worked at Boeing, who couldn't leave anywhere else, and I decided that, okay, I'm going to have to stay in Washington. Making that choice that not because, I feel like I have to attach myself to him, but because I realized that I can make a career out of anywhere I feel like I can go, but I can't rebuild what I have now, and now he's my fiance. So that's kind of like the closest thing. Yeah.
Congratulations. Okay, how about, is there something you wish you had known earlier in your career that proved to be invaluable, some kind of lesson? Start with Rachel.
So this is a funny question because I feel like we spend our entire lives learning, and as much as I can look back and be like, oof, I really wish I had known that, like technically, I wish I knew everything all of the time. There are things that next week Rachel will look back and be like, locating pins, really? That's not that hard. Like, I wish I had known that. But there are some things that I think it would just, not to eschew the learning and growing process, just, I don't know. One thing that really comes to mind that would have been good for past Rachel to know is just that, more people are on your side than you expect. If I had realized how willing so many people are to be your personal advocate when you need one, there are so many uncomfortable situations in school and at the DOE and places that could have been much more easily resolved and very just lightly, oh, right, this person is actually probably going to side with me in this instance. But because I didn't realize how willing people are to, be your advocate and, people want to be here for each other. And most of the time, if you see something and you're like, I think I'm in the right here, other people will think you're in the right too.
Awesome. Vicky, what do you think?
Sure. One of the things I've learned will become useful anywhere, really, is just paying attention to how people think. Kind of one of the important places that I learned this at is as a PhD student, basically everyone spends time teaching classes. And so being able to interact with students and think they're seeing this information for the first time, how are they going to be processing it? And think about how you want to lay it out for them. We have experience, you can write a very technical research paper that's peer-reviewed and meant for other scientists, but then you can take that same information and have to explain it to someone who's not technical at all, and you basically kind of have to translate it. And so looking at how people accept information, how you want to cater it towards them, super important, and especially important for anyone in a technical role to be able to convey the importance of your work, why you need to do that, being able to advocate for yourself, for people you know, and really just making information more accessible. And it's interesting to pay attention because, us up here, we're more analytical. We like being able to look at data all the time, but a chart might not mean so much to someone else. So being able to maybe add a story or communicate in their own language, so to speak, is something that you can take anywhere.
Awesome. Erin, what is a lesson you learned that was invaluable?
What imposter syndrome was, and I wish I had learned it a lot earlier because it hit me like a brick wall. It feels like just to some extent, I was coasting along as a little baby engineer, and I still call myself a baby engineer, but I was a really big baby engineer, small baby engineer, whatever you want to call it. I was like, okay, I really don't know things. And I started progressing and becoming a little more senior. I was like, oh, I don't know if I can do this. And you know how I mentioned before, an MRB or material review board, people were coming to me and asking me for all their opinions. And I was like, I don't know if I'm qualified for this. Somehow I got this position, but I don't know if I can. And realizing after going to conferences and talking with people all across different levels of experience that to some degree, a lot of people experience imposter syndrome. And as much as sometimes you try to do your mantra, you're just like, all right, I can, and I am capable, and I need to be confident. It always comes back around. If I had known what it was, like a little bit earlier on, I'd be like, okay, all right, I kind of get what's going on here. So yeah, that's a big key thing. I think that's also a really popular topic right now in our industry, and also with women in particular, is that imposter syndrome. Yep.
Who here in the audience has had imposter syndrome at some point in their career? Look around. It's everyone here. So thanks for saying that. What about you, Rama?
So I would say what I should have learned earlier was speaking up in meetings. And that's because people valued my opinion. And I think if I had done that sooner, then maybe things would have changed quickly. And I noticed that I would be sitting in these meetings and people would be going in circles. And I'm like, if I just stated one thing, we could have stopped the going around in circles and come to a conclusion or a solution. And so like later on, I realized this and I started applying it, and then people started adding me to more meetings. And I was like, okay, so yeah. But like basically people valued my opinion, and it was known that like, hey, Irama has something to say, and usually she says something pretty well profound and also helps everybody come to a conclusion. So I definitely recommend, if you guys are not speaking out in meetings, to try to say what you think in the moment, you know, because you never know where that could lead.
Awesome. I'm going to pivot a little bit and talk about design for manufacturing, which is a common term, a much more used term, but how do engineers design something so manufacturers can build it? I run into all the time engineering drawings that call out material that's so far out and wild and hard to get. And there's sometimes a disconnect between engineers and the people producing these parts. And how can we kind of combat that? Start with Rachel, and especially you have a history of machining and working 3D printers, so you can definitely kind of understand that. So tell me about that.
I don't know. This is kind of a soapbox issue for me because I just love building stuff so much. So for several years, I worked in a machine shop, first a wood shop, and then running a water jet and like a 3D printer, print farm and such. And design for machining or design for manufacturing is a super, like, I don't know, sometimes it's easy to exist in the CAD world and forget that reality exists. You know, people try to print things and they don't realize that gravity is going to affect that. And then, or people try to machine something and they don't realize that the tool has to be able to access the inside of this hollow box that you're machining. So I think the most important DFM thing that people can do is, if you're an engineer, machine something, build something. Just like go over to a mill and like have someone show you, even if you're not operating it, just like know the process, watch the process. If you're a machinist, CAD something. If like, I feel like either way, if you just dip your toes in the other side of things, suddenly you get a much better sense for like, oh, this partially defined drawing, right, if I were making this, then I would assume that it was symmetrical over the x-axis. Therefore, if they didn't design it, like, I'll check. But, like, probably this is just symmetry and then everything's fully defined. Yeah, I feel like it's really, really useful to know the tool options that you're working with, because different things, like, different tools are so much better for different types of manufacturing. Things like tolerancing, or like, there are some parts that are incredibly easy to 3D print and incredibly hard to machine, or vice versa. And a lot of times, depending on what material you use, you can mill that plastic, or you can print it, or you can laser cut it. Like, you can make stuff out of sheet metal, or like do some other thing, and like one is going to be way more effective than the other. So I think just being aware of the whole process, and especially knowing what your options are, can really help your design for manufacturing get a lot more efficient and usable for everyone in the process.
And cheaper. And cheaper. Erin, what do you have to say about design for manufacturing? And
I completely agree with Rachel in getting that kind of experience. One other point definitely is to communicate. Even when you may not have that opportunity to go back there and work on it, talk with the people who are actually working on it. My fiance, he's an airplane mechanic. I went through the entire part of school of him talking crap about engineers. And I was like, okay, I won't do that. I promise I won't. Coming into the situation and coming to my fab guys or fabrication guys or my operators and telling them like, hey, honestly, everybody here, I'm the dumbest person. I do not work with this on a daily basis. I want you to tell me what's going on. I want to create like a comfortable space and realizing like you have an equal, if not more important opinion on how this is going to work more than myself. And I'm here to learn something from you. Breaking down that barrier constantly. These people should be included from the beginning of the design all the way to the exit. Everybody, it's a whole team. The product doesn't just come out. But yeah, so in my opinion, it's definitely communication and just making sure that everybody actually has a spot at the table when it comes to creating and manufacturing a product for the first time.
Awesome. Hey, Rama, what do you have to say about design for manufacturing?
So I think they all hit on all the points. Rapid prototyping is very important to be able to get the people who are building their hands on it and to be able to try it out and give feedback on it. I think definitely communicating with manufacturing counterparts, manufacturing engineers, tooling engineers, the operators, even the supervisors who don't know what's happening, can give you input into the design. So I would say just all of those combined will help you develop a better product. And the faster that you can do iterations, the better your design and your product will be.
Awesome. I think we're starting to get to time, so I'm just going to ask one more question. I want to leave a couple minutes for the audience to ask questions. What advice would you offer someone getting started in engineering or in manufacturing? I'll just go down and start with Rachel and go all the way down.
My biggest piece of advice is build stuff. You're going to get way more out of just building something, taking something apart, just being here's a home improvement project. I want to try to build a robot bunny. Why would I buy a pinball machine when I can just build one? Just whether or not it succeeds, you'll get way more out of trying to actually build stuff using whatever materials you have on hand. Even if it's just I don't know, paper, making your own wall art, actually physically building stuff is going to teach you a lot more than reading or listening to people talk about their stuff that they've built. Build stuff early and just keep doing it. And if you find something you hate, don't do that again. And if you find something you love, keep doing it.
Awesome. Vicky?
I think if you listen to our introductions, one common thread you'll find is that we were all part of groups, organizations that kind of helped lead into the next step. So I would encourage to find groups. Women in Manufacturing is an excellent one, who have a collective interest and have resources. You don't know what you might learn, who you might run into, what you might find that you never knew about before that could totally change your path. So I highly encourage to take advantage, and it's going to be what you make of it.
Erin?
Sorry. Finding mentors at different stages of every part of your career and finding different kind of mentors for different things. I remember distinctively about when I ran into WIM as a college student, and when they reached out and I volunteered for some of their opportunities. I remember being incredibly impressed and seeing these this powerful group of women, as those at that time as a type of mentor for me. Also finding different mentors in my workplace and also just in life.
Awesome. Yeah, Erin helped with a conference we had in 2020, and it was all virtual. It was the middle of COVID, and she stepped in, and it was just awesome. And I know she says that we're awesome, but we learned quite a bit from her too. So that was fun. Hey, Rama, what advice do you have?
So I would say be resilient, because you're going to fail a lot throughout your career, whether you're getting a degree, whether you're in the entry level position, even years down the line when you're more senior. So being resilient and being able to bounce back from failures. And then you can also talk to the experts in your field about the failures that you had and be okay, this is what I did. Are there any ways of thinking that I could go about this a different way? So being resilient throughout your career will help you grow and also keep you going, and staying in your career.
Awesome. Well, what questions does the audience have? Oh, look at that. I should have known. Marie?
I have a really easy example of this, which is just different technical expertise. Manufacturing doesn't change that much over time, but it also does change a lot over time. So, I have a coworker who's a very, very new grad, and then a few who have been in the workforce for like 10 years or so. And the other very new grad and I have had to teach everyone else on hardware how to use our 3D printers and things like that. Because that's a skill that we learned in high school because printers were around for our high school and they just weren't 10 years ago. So, I don't know, different familiarity and like we're native to a different set of technology.
I can also give an answer. I think something also that's very new for current generation is just the vast amount of information we have access to. And it's not about knowing things, it's about having to filter through it and get the information you need and being able to be so critical and swim through it all. That's something that, before if you had to look through books, is very different when you just have the computer.
Erin, Vicky, Rachel, and Rama, a big round of applause. Thank you so much for joining us for the Engineering and Design Fundamental of our Manufacturing Fundamental series. Some of the key takeaways from the panelists today are that imposter syndrome is real and that we need to have more confidence in ourselves and realize when we are feeling like imposter to try to overcome that. And mentorship is key. And a lot of these fabulous women got to where they are by networking and building a community around them.